Perfect. In that case, hello everyone and welcome to the very first webinar of the Preparing for the PAT course 2025. My name is Kat, my pronouns are she, her, and I'm the Access Officer for the Department of Physics in Oxford. That means I run most of our programmes for secondary school students, including all of our stuff to support people like you who are interested in applying to study physics here at Oxford. This session is being recorded as well as being live streamed on YouTube. Hello to anyone over there, and I'll make it available to you tomorrow. Quick reminder of the housekeeping rules for us. At the moment, you are able to use chat. At certain points this evening, I will be switching that off so that we can process some problem solving together. You also have access to the Q&A for specific questions which are relevant. All we ask in the chat is make sure you keep it polite, don't share any personal information. Without any further ado then, let's get started. Before we jump into problem solving, I'm going to give you a very quick introduction to the course and to the PAT itself. I'm not going to take questions in this part of the webinar, but don't worry, we have plenty of time for questions later. First things first, the PAT is the Physics Admissions Test. It is the required test for all candidates for physics, physics and philosophy, engineering and materials science at Oxford. And the result of your PAT test forms part of the information which admissions tutors use to decide who to shortlist for interview. To sit the PAT, you will register yourself as a candidate. Your school will not do this for you, and we will help you find all of the information you need to be able to do that. As was the case in 2024, the PAT this year will be on screen and multiple choice. We've worked really hard over the last couple of years to make sure that this means that the experience has changed as little as possible for you and that we can still gain as much information as possible. So the answers are not simply 1 mark or 0. The syllabus is unchanged and the questions will be very similar in style to previous years, so all of our past papers are still very much relevant to you. The online test has a built-in on-screen calculator and it looks exactly like a picture of your regular calculator and works in the same way. There is a practice version of this. I am going to switch off the chat so that everyone is able to listen because all of the information is going to be shared. So at the moment, you cannot access the chat, but it will be switched back on in just a few minutes. That is our very basic physics admissions test. Now I need to tell you about the course itself. So this webinar is part of the PAT preparation course. We run this in the physics department on behalf of all subjects who require the PAT. The Preparing for the PAT course is a set of 8 webinars along with problem sets and summer assignments. And we hope this will provide you with all the information you need to take the PAT, to help prepare for the PAT and to be confident going into interviews if you are shortlisted. The timetable on screen at the moment is part of the timetable which is at the bottom of every PAT email, and I always have it highlighted in yellow so that you can easily follow our progress. In each session I'll fill you in on any updates, any deadlines and any news as we get closer to first dates. As you can see, today we are in our first webinar and we are focusing on problem solving skills. All of the information about the course and all of the course materials are on the course material page. And I link to this in every email. At the moment, the page looks something like this. And you can see we've got a few things highlighted in pink. The introduction to physics problem solving has some general hints and tips, and Rachel is going to be taking you through some of those this evening as well as more. Underneath, there are links to everything that you need. At the moment, there is only a link for the problems used in Study Focus 1. But you can see that after tonight, the link will be available and the problems to solve in advance of webinar 2. So this page has everything that you need, and that should answer questions about recordings and things like that. Finally, just a quick reminder that all of the information that both you and your school need can be found on this main page. I'll share that link in tomorrow's email, and in fact in all of the Preparing for the PAT emails. It's down under the course information section. That is the most up-to-date page, and it's the one to check first. It is any information that you need. It also has a really useful FAQ page which they keep up to date. Some key facts to finish up. All PAT tests this year, whether you're joining us from the UK or whether you're an international candidate, will be sat at Pearson test centres. There are venues in almost every country around the world, and when you come to select a test centre, you can book either locally to you or further away. Hopefully, you will never need to travel too far. This arrangement is exactly the same as the setup for tests like the LNAT, the BMAT, and for the Cambridge admissions tests as well. The test format, which I mentioned earlier, the multiple choice on screen, it was new last year, but the questions were and are again really similar to our past paper. Syllabus is unchanged. You can access a version of the paper, practice version, to get used to the calculator via the on-screen link, which is up there now. We also have some key dates to remember already. So registration for the PAT will open on the 18th of June and will continue until the 19th of October, but actually booking that test centre is a slightly different window. One final thing before we move on, which is that we do run some additional support sessions. They are specifically targeted at students who would most benefit from additional support. You can check the eligibility for those sessions and you can apply via the targeted PAT support page, which is up on the screen and will be shared with you tomorrow, as is the case with all these other links. That is my quick PAT introduction and update. I hope it was helpful. I will take questions if we have time at the end today, but for now I'm going to stop screen sharing and I'm going to hand over to our lovely Rachel for our first PAT study focus session. Rachel, hello.
Hi, thank you so much, Kat, and hello everybody. Thank you for joining us this evening. I am leading your first study focus session on how to turn words into maths. So I'm going to share my presentation and I'll be talking you through some things today that we're going to practice. So make sure you have a piece of paper today in front of you, your calculator, but the calculator will always be used in the final step, please. And I'll go through some other expectations for the session today. So,
Rachel, would you like me to share a link to these questions in the chat? Would that be useful while you introduce the session?
That would be useful. Fantastic. Thank you so much.
Absolutely.
Brilliant. So in today's session, this is why it's helpful that Kat is sharing with you the questions for today's session. I would encourage you to work at your own pace, and I'll be providing hints and tips for each of the questions. So you can open the link that Kat has sent, and if you're working faster, that's fine, and then check in for the answer for each one, or you can work along with me as I explain things as we go along. So make sure you've got that piece of paper, your calculator at the ready. So if you're faster paced than me, then great, keep going. And if you're slower than me, also keep going. That's the point of this first session. Problem solving is a skill that can be learned and practiced. So come back to questions. If there are any questions today that you don't finish, you can come back to them independently later this week. Don't leave it a couple of weeks. You want to practice them before your next online session. For today, the chat bar, please can you use that? Kat will change the settings shortly, but I know she's just sharing the link with you. In the chat bar, can you write your final answer? But we're going to change the settings so only me and Kat can see those. So we don't just have, too many final answers flying around, but I'll give a bit of feedback as and when I can. I can't give feedback to everyone though. There's a lot of you. It's amazing. And the Q&A, that will be really useful for if you have any question to ask. So if that is a question to ask me about the session I'm running and about the questions I'm going through, or if it's a question about the PAT, that is a question for Kat, or if it's a question about this course in general, put those in the Q&A. So you should see those buttons at the bottom of your Zoom screen. Fantastic. So Kat has shared the link again to the questions, but all the questions also today will be on each of my slides when we get there. And my final tip, just in terms of admin, is make sure you complete the sort of homework tasks and summer tasks this summer. So make sure you practice over the summer, and you'll have some more sessions after the summer as well. The more you practice, the better you get at problem solving. So in terms of actual physics tips, those were quite generic. Hints and tips. At A level and for physics, you will need to decode questions. And what that means is you've got to get really good at turning words into physics. So in the language of the question, we'll have to break it down today. Next, you need really clear layout and working. So that's going to help you when you're trying to find the answer for the multiple choice questions. If you can track back to see what you've done and checking your answer, you need your working there on the page. Don't rush to start the question. Lay out the formulae you're using, or lay out your decoding from English to physics on your page. Underline key information in questions, if you had a printed one, or you can think about what you would highlight in the question today. Really think today, you probably already do this in your physics lessons, how would you turn words into symbols? And you can use subscripts. So if you're being specific about the speed of the car, or the velocity of the car, I should say, I meant to correct that, you might use V subscript C, as you can see there on the slide. And if you're being specific about the weight of the passenger, you might use W subscript P. So you've probably seen things like this in your physics lessons, or you're using them already. For example, if X is twice Y, then we decode that in a question, and that's going to be relevant for a pretty tricky one today. X is equal to 2Y. So we decode that, and you've been doing that in physics and maths. And do always remember, this is where you've got to have your broad physics subject knowledge, your conservation laws. So your law of conservation of momentum and conservation of energy. Other things and tricks are in particles, like we always know the charge of an electron E, or you know what it is that you've been working with. So if you were working with an alpha particle, which is 2 protons, 2 neutrons, the relative charge would be 2e. So think about how you can break down a question to problem solve it. But we're not dealing with any particles today. Some units are equivalent. We're going to do a question on that. And so as a hint, you might want to write down for later, if we know acceleration in meters per second squared, we actually also know it as newtons per kilogram, newtons kg to the -1. You might know that from your physics lessons, because that's a common method you need to use for showing that two sets of units are equivalent. Because force from Newton's second law is equal to mass times acceleration. And then if we insert the units, we know that newtons, therefore, is equal to, sorry, sorry, you can decode it. We'll do that later, actually. I've just given away something we're doing later on, I've realised. And projectiles and SUVAC questions. We're going to do one of those today. There's loads of unsaid information. So if you see, and we're not using that in the question today, but the word dropped means that actually the initial speed of an object is 0 meters per second. Also, just like in A-level questions, or whatever level you're working at now, there's going to be decoy information or data in the question, information that you don't need to use. And we'll do some questions with that as well. So you don't always need to use maths in questions. So the first question is on the screen now. I know you said on the board, I'm used to teaching. I forgot to introduce myself. I'm a physics teacher and head of science in West London, and I've been taking part in this course for quite a few years now. So have a read on the question. There's some reminders on the board, and I'll speak again in about a minute, but get started when you're ready. So thank you so much for the answers that are already coming through. I've got my eyes on multiple screens here. That's great to see plenty of answers. And it'll be really key where to decide where to start this question and what assumptions to make. You might do this more than one way, but I'll show you my steps for this question. So we've got some very speedy answers coming in. Make sure we can simplify them as much as possible, but I think every answer I've seen so far, and I might have missed one, but I'm pretty sure every answer I've seen so far is correct. So if you're typing them into the hosts and panelists line, if you'd like us to see them, then we can see your answers there. Okay, kind of helpful for this one if you put them all in one go. But if you're thinking, oh, where do I start with this one? Then it's a real assumption that we're only taking one button. You may assume, sorry, that we're only taking one button at a time and replacing it in the jar before selecting the next one. That's key information. In this question, we're going to turn words into symbols, and the question is about probability. So we know that the total buttons in the jar, n, are the number of yellow plus the number of green plus the number of red plus the number of blue, and that will come in handy later. But turning the words into maths, from this first section here, there's twice as many yellow as green, etc. The number of yellow is 2 times the number of green, so using subscripts. Number of reds, twice the number of yellow. And you can see I've turned the words into maths. Fantastic, you are all excellent at this question. So you can either solve these equations simultaneously, but my preference is to just make an assumption that the least number of buttons we must have are the green ones, but you could make an assumption for any of these buttons as long as that's a whole number. But I'm going to assume we've got one green button, and that's going to start me off solving this question. So if I've got one green button, that means I must have 2 yellow buttons. And that therefore means, using the rules up here, that I have 4 red buttons. And then I have, therefore, using the final rule, rule number 3, that's why I'm numbering my rules, I must have 8 blue buttons. I already know that I put each of those buttons back each time. And the total number of buttons, if my assumption that I have one green button is going to work for this proof, is that if I add all of those together, that will be my total number of buttons. So well done. We're going to assume that we have 15 buttons in total, and I've seen plenty of answers, well done, that the probability of getting a green button out of the jar is 1 in 15, all the way up to getting blue, or down even, I should say, up even, which way is bigger and smaller. Sorry, it's been a busy day. Blue is 8 over 15. So you can actually test that if you want to test the assumption. You could decide any value of green buttons, and you'll still end up with those probabilities. Probably fix the list, no problem.
Oh, I think we're having a few
Otherwise, we're going to
connection
look at the
issues,
next
unfortunately,
question.
Rachel, just to
And if
let
you're
you
having
know.
internet issues, don't worry, just join back in. Is it still causing a problem, Kat, or has it come back?
Yeah, we're just a little bit
The audio.
jumpy, but hopefully it will sort itself out. Ah, there you are. You're back and moving again now. You were temporarily frozen. Wasn't it impressive how quickly everyone got answers into that question, though?
I saw a comment, a question now. Okay. And have a read through of the second question.
And for those of you who have spotted that the link that we shared had answers, absolutely, just don't cheat.
So the link with the answers is so that if at home after the session, there are any questions you couldn't quite follow along with, you can check the answer at the end of the session. But obviously there's no point looking at the answers right now, because it's about working on your problem solving during this session. So I've got some answers. I'm just going to let you know that 45 degrees is not correct. So have another look. And 30 degrees is not correct also. Okay, but thank you. We've got a few correct ones as well. So the next part we are looking at is how to break this down. So in a projectiles question, this is a projectile because we are launching a projectile from a moving carriage. So we have a projectile. The unsaid information is that the vertical acceleration is always going to be acceleration due to gravity. And I'm making a decision that downwards is negative in this part of the question. If the small rail car is traveling at a speed of 100 meters per second, it passes the gun just as it is fired. That means that they're in the same frame of reference at the point the gun is fired. They're going to have the same time for both. The time is going to be the linking factor. We make an assumption the gun and the car are at the same level. So at the end of this motion, there's no vertical displacement because we want to know the angle that the projectile must be fired in for it to land in the rail car. And everyone just make sure that your calculator is set on degrees before we carry on. So the irrelevant information is that the mass is not required to solve this SUVAT. Fantastic, lots of correct answers coming in, well done. So it always helps with a challenging question. We're not too challenging yet, we're still warming up our brains, to draw a diagram. So here's the diagram of the gun passing the small railway car and the information that we have in the question labeled, as well as the information, the angle theta that we would like to find out. There is one shortcut. I wonder if some of you already found it. If we're using SUVAT and going through every single step, we are going to lay out our SUVAT. This is how I teach my students at school, and put in the information that we already have. So we know for the full motion, there's no vertical displacement. And so we're going to only focus on breaking down SUVAT in the X component, because at the end of the motion, the gun ends up in the rail car. So we know the information about the velocity at the beginning, the velocity at the end. Well done, Daniel. I've seen some excellent shortcuts there. Another excellent shortcut. Good, so you are spotting the shortcut in terms of, I'll give you a clue, the horizontal speed. You can see it right there with the car and the projectile. So we have time linking them both. Horizontally, there is zero acceleration using the information in the question. And to land in the cart, the displacement has to be equivalent to both. So if we're using ut plus half at squared, well, there is no horizontal acceleration. So that means that ut for the car is equal to ut for the projectile. And working that through, we get theta is equal to 60 degrees. Well done for those of you that identified the shortcut. For the projectile to land in the car, the horizontal car velocity has to be equal to the horizontal projectile velocity. So these two velocities have to be equal anyway, which is what we have eventually proven mathematically. But well done if you found the quicker route through that question and did your problem solving a little bit more speedy. The more problem solving you do over time, the quicker you will get to the final answer. But still, going systematically through every step will still lead you to the correct answer and will help you learn along the way. So that was the shortcut. The only possible way for that projectile to end up in the rail car is for the two horizontal velocities to actually be equivalent. So really make sure we're thinking about this in terms of velocity and time. We're not looking at forces in this question, and the mass is actually completely irrelevant in this question. It's just there to confuse you, decoy information. I'll move on to the next question, and this is a longer one, where the first hint I'll give you is that you really need to focus on how you'll turn these words into symbols. I'll give you a minute to read and start that. As you get answers, pop them in the chat bar. And remember, questions in the Q&A, because it helps us keep an eye on them. Oh, sorry, did a classic. Just been speaking without my microphone on. So remember, questions in the Q&A, and Kat's given us a reminder as well, because when answers are coming in, they come in very, very quickly. Okay, so I have seen about 2 correct answers just now, from Zarin and from Timothy and from Finbar and Colton. But we've had a couple of incorrect ones, and that's fine. I'm going to show you the steps. And don't worry if you're right at the start of this question. That is no problem whatsoever. So I'm going to show you how to break this down from words into maths. So I won't be able to give feedback on answers for a bit, but see if your method matches mine, or let me know if you used a different method in the chat bar. So turning each of those 5 statements into maths, don't just do one at a time and do a bit of the question. Turn them all into maths straight away so that you can work with them. So that's a little bit of maths there, because we've got 5 mauve caterpillars as long as 7 violet caterpillars. As long as is talking about length, you might have used distance or a different symbol, but I'm using length for these. And we've also got the idea, particularly if you break down statement number 4, sorry. A lavender caterpillar takes 10 seconds to crawl the length of a violet caterpillar. So we've got that statement with length involved. Statement 5 actually was the one I wanted to talk about. The violet and mauve caterpillars both crawl twice as fast. So that's a comparison of speed, twice as fast as the lavender caterpillars. And remember, if you've just put a question in the chat, can you click on Q&A instead and pop that question there? If we don't address it now, we'll address it in a few minutes. So we've turned those statements into some symbols and subscripts. And then again, my next step is turning those symbols into equations. So when we're comparing, I always think statement number 5 is the hardest. They crawl twice as fast as the lavender caterpillars. That means the velocity of the violet caterpillars is twice the velocity of the lilac caterpillars. And the same for the mauve caterpillar. So there's multiple routes through this question. I'm going to show you one route. And remember the end goal. So when you're in a challenging problem-solving question, you've got to think, what was the end goal? What was I trying to do? There's multiple simultaneous equations here. So how long would it take a mauve caterpillar to crawl around the equator of Pluto? I will need to know the velocity of that mauve caterpillar, because I've got the radius of Pluto, and that means I can find the distance involved with the circumference. But fundamentally, if I've got velocity, I need to eventually find the time. That's how long. That's what the statement how long means. So my first step, and there's multiple different routes, you might have done something different, is substitute equation 4 into equation 5. And if I substitute equation 4 into equation 5, the velocity of the mauve caterpillar will be twice the length of the violet caterpillar over 10, which we can end up simplifying. Now, next I'm going to look at equations 1 to 3, because I've got a bit further, but not that much, because eventually I need the mauve caterpillar's velocity. That's why I started there. But to get the mauve caterpillar's velocity, you might be like, where do I go next? I'm going to go here and think about, how do I get the length of the violet caterpillar from the information I am given? Okay, well done. Another few correct answers, Ava, Chineza, and Emily. Well done. Haven't seen all of them. I'm looking at 2 things at the same time. So we're looking at equations 1 to 3, and I'm going to solve these simultaneously. Equation 1, although it's only got LM and LV in it, that means we can rearrange it and put it in a very similar format to equations 2 and 3. So I'm lining up all my equivalent symbols, so LM, LV, LL, which is good practice for laying out our working for a simultaneous equation. Then I can do my next step, which is to choose a term to eliminate. We don't need LL. Remember my goal, I need LV at some point. So from these equations, I can see that I can eliminate LL if I multiply equation 13 by 5 over 3, by 5/3. So I'm going to do that now and show you that next step. You might have taken a different route, but if I multiply equation 13 by 5/3, I'm going to then subtract that equation from equation 14 because I've got 5LL there, 5LL there. The reason I multiplied it by 5/3 was to get equivalent amount of the length of lilac caterpillars. So it's quite a mouthful, this question. So I keep calling it LL. And when I subtract that new equation, that is still a correct relationship there, I end up with, sorry, it's moved it to a different position, the length of a mauve caterpillar in terms of the length of a violet caterpillar. With this new term, I can then substitute that into equation 1. And the reason I'm choosing that equation is I've only got the length of the mauve caterpillar and the length of the violet caterpillar in that question. So I'm not bringing in the length of the lilac caterpillar again. I've also already dealt with those two equations earlier in my substitution that I was doing. Simultaneous equations, sorry. So I'm going to substitute LM into this equation. And when we do that, we can work it through. And you find out that the length of a violet caterpillar, so this middle bit is the hardest bit of the question, just to clarify. And I can find out, because I've substituted in LM, that means I've only got LV. If you look at where my laser is, I've only got LV in that equation. And I end up finding that the length of the violet caterpillar is 0.05 meters. Have a go at the next step if you haven't got there. Well done, Rosa. I can see you've corrected your mistake. I will just say now, for those that are asking for feedback, but carry on if you haven't got there yet, that the final answer for the time is 7.4 times 10 to the 8 seconds. So absolutely fantastic. Well done.
I'm not sure it's strictly relevant, Rachel, but I have to say this is one of my favourite problems. I absolutely love it.
I love it, apart from having to keep saying lilac, mauve, and caterpillar a million times.
I think when you said it's hard to say, I was like, it is, but it's lovely.
I love this question. We should do more like this in life.
For those of you who are looking for extra practice at this, there was a phase where the Oxford Pat had one of these almost every year. So if you go back through our past papers, you can find not just caterpillars crawling around planets, but you can find one about various sized rubber ducks, one about various sized spaceships. There's one about different cubes floating in different liquids on the surface of planets. They are a delight. And if you watch them alongside Rachel's explanation, you'll be able to get through them as well.
And I think the key is, because I remember when I first came across this question, the key is always thinking, what is the final thing I'm trying to find? Trying to find time. Okay, is time for which particular caterpillar? So you're always trying to prioritize solving for any details to do with the mauve caterpillar or the routes of how to get there. So when you get, if you get lost in the middle of the question, always think, okay, where am I trying to get to? What's my goal in this question? Just remember, everyone, any questions need to go in the Q&A, but just answers in the chat to us when you're ready.
The reason I have my camera off quite often is that I am answering all of the questions in the Q&A and I go a bit strange looking. So please do pop them over. I'm getting to them all.
Yeah, and I'm just trying to keep an eye on the answers coming into the chat when I'm busy also looking
Teamwork.
at my screen. So we're working as a team here. That's why we keep asking for questions in the chat. Questions in the Q&A. Fantastic. So lots of people are on the last couple of steps. Well done. Like the middle bit of this question is the hardest part of the question because you've got so much information and you have to prioritize where am I trying to get to. So there's multiple routes. I'd love to know in the chat bar if you took a different route, but I prioritized working with my velocities at the end because I knew I needed velocity to end up finding time, just to recap. And then I prioritized how am I going to find the length of a violet caterpillar? It has to be these equations involving length, solving simultaneously and prioritizing eliminating LL because my final equation has LV in it. And I've got one equation here, that was the other way I prioritized it, that has LM and LV. Maya, it's times 10 to the 8. Just double check, maybe it's a units thing. You're very close. So then where we got to, just to recap, is substituting in when we solve simultaneously the length for LM. And when you substitute that in, we'll only be working in terms of the length of the violet caterpillar. And that's where we have a length of 0.05 meters. Fantastic, more answers coming in. And you see problem solving, we're working at our own pace. That's exactly the point of this session. Well done. So the next, and that's going to be important in this problem solving. And when you substitute that in, you get 0.01 meters per second. And then in this long question, you have to remember, what am I trying to find out again? I'm trying to find out the time for the mauve caterpillar to crawl around the equator of Pluto. So I'm finally going to use the radius of Pluto, noting the units are in kilometers. We can't work in kilometers, we have to convert our units. So the final step is thinking, well, Pluto is we're modeling it as and crawling round the equator of Pluto will be equivalent to crawling around the circumference of the sphere with this radius, 1,180 kilometers. So the circumference is 2 pi r. We converted into meters. Some people might have missed that step. And then we are dividing by the velocity, the speed of the mauve caterpillar, the velocity. Direction is constantly changing, however, so we'll just go with speed for now. And we've got 7.4 times 10 to the 8 seconds. Well done, lots of answers coming in. And I've got Ryan saying he tried to solve for the worm velocity to find the length, so I've just lost where that went. Well done. So that obviously is a jump up in terms of challenge in terms of that question. And Ryan, if your route still got you to the point where you were able to find the lengths for each worm, as long as it got you there, but this probably still is the quicker route. I'd love to know if someone found a quicker route. Teach me something every day. So I will shortly move on to the next question. If there are questions about it, this question, let me know. And I just saw Nicholas's question about the answers for the other 3 problems. I think just put the answers in when I'm on that question. Otherwise, I won't know which number you're talking about. There are 200 of you, and I've got loads of answers coming in, so thank you so much. But keep working at your own pace. That is great.
There is a question about a previous question as well. So at some point, if you have a break, I think there is a person who'd like to see the velocities being resolved, if that's all right.
Okay,
Just
brilliant.
we've got a good time to show that slide, but we can always show it at the end.
Fantastic. I could go back with that for a moment before we change the theme of some of our questions.
Perfect.
So in terms of resolving the velocities, what's the best way to explain this? So we are, possibly I need to draw a diagram actually. So I might put the next question up, but it's about remembering that U is the initial velocity, V is the final velocity, but because we are working in an arc, I'll do a very rudimentary diagram. Oops, that's all the slides. And we're just thinking about, apologies for this, the first part of this, imagine that's a straight line. And then breaking that down horizontally, I'll do some dots here. That is not horizontal at all. And looking at the x component of that initial velocity when we're launching the gun. And the horizontal component, here's my vertical. Because the angle that we're interested in is this angle theta, probably better if you look at the angle over here. So the angle to the horizontal, using trig, I know that this base x dimension is the adjacent component for that angle, for this vector triangle. And my hypotenuse is 200 meters per second because the question says that the gun is launched at 200 meters per second at theta to the horizontal. So we're using our vector triangle, we're using trigonometry where the adjacent, when we're trying to find the adjacent side using our hypotenuse, we know our hypotenuse is 200 meters per second. So our adjacent has to be 200 cosine theta, because the rule for adjacent side over hypotenuse, that's for if you're doing cos theta, is adjacent over hypotenuse. And so the adjacent side, which is what we're trying to find, is the hypotenuse times cos theta. Okay, and let me know in the Q&A if you want more of a diagram, because I think I need to use my an extra slide for that and my computer a bit more. Okay, so I'm going to put the next question on up now. And we're coming back to units. I gave a hint on this in the warm-up. Have a read of that question, if this is the first time you're looking at it. And some people have looked at it already in the booklet. And I'll give some feedback to you in a moment.
Lovely. While Rachel is giving you a chance to problem solve, I'm just going to address a few questions that are coming up kind of constantly from me in the chat that'll hopefully help you out. There are a lot of questions about the multiple choice format, and I've got two things to say there. So firstly, last year I ran a whole webinar where I focused on what that multiple choice format looks like, how to navigate through the test platform, and how to use that to your best advantage. I will share that with everyone at some point in this year's course so that you can get the benefit of that webinar as well. So we will absolutely make sure you're confident using that. But in brief, yes, you are able to go through, navigate back and forwards and move around as you need to. I would also like to reassure everyone that we absolutely make sure we can get loads of information about you, even though it is multiple choice. And again, I will talk all about our behind the scenes and how much fun we've had in a slightly strange way, making sure that this is fair. Rachel, you'll probably be interested to know, to work this out, we released a set of postgraduate particle physicists onto our data. They've been helping us write the algorithms behind the scenes to get as much information as we can.
What a great project.
They've had a lot of fun.
They'll really enjoy that, looking through all the data. I love data at work, let alone at the level that you guys are working at as well. Fantastic. So lots of brilliant answers coming in for this question, and that's coming back to that skill of really thinking in this question here, what are the units for each of the terms you're given? Even though you've got the viscosity of the fluid and it's a coefficient, but we have the units for that new term at the end of the question here. So well done, lots of answers coming in. I was just looking at the questions as well. So remember, any questions, or if you're unsure about something, best to put that in the Q&A. It can be anonymous as well, that any questions do help us to see. So well done. Lots of people have identified. I think every answer that I've seen come in on the chat is correct, because the final answer is that all of them end up being 1. So just double check. If you have got any of X, Y, and Z not as 1, make sure you're really listening closely now. And I'll show you what I think is the most straightforward way to work through this question. So I've said we're given units here. Now, obviously, you need to identify the units for R, radius, it's a distance, working in meters. V, velocity, already been working with that today, meters per second. And force, that's where we'll need to do a bit more in terms of our derivation. And I almost gave you too much of a hint earlier on that. So the units must be identical on each side of the equals. K is a dimensionless constant. So it becomes irrelevant. There's the decoy information. It's irrelevant in this question. And when we're breaking that down, we ignore K. I've got all my units written underneath. And you might have written this instead with certain symbols for each of these terms. But I'm just going to show you in terms of straight units and thinking about the powers on each of these terms in the equation you're given, and how that kind of correlates with the powers on each of these units. So at the moment, I'm just going to think about force in terms of newtons. but we're going to need to break that down, that unit later on. Radius, I said meters. Coefficient of viscosity, we've got the new units here that we were given, but we recognize all of them. And I'm still putting the powers by each of these places. So this is me showing literally every step. And we can ignore the constant because the keyword is dimensionless. Remember, I actually just did see a question in the chat. Sorry, am I lagging again? We'll see. So the dimensionless constant, dimensionless means it has no units, it's just a number. So it's just a value that is needed to make this equation work, I suppose. A bit like, I'll come back to one later, but a dimensionless constant, I guess a bit like pi. No units on pi, it's just a number. So when we think about all these terms, we can see we've got meters, 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 but with different powers. So you've got to show you're working really clearly. And well done, all of them, X, Y, and Z are 1, but make sure you are clear on how to get there. And you've got to show every step. So you can also use this terminology. I was predicting my next bit on the slides. That's what always happens to me in teaching. And I'm going to break down newtons to its SI units. So remember I said Newton's second law, F equals ma. The mass is kilograms, units for mass is kilograms, and acceleration is meters per second squared. So that's why I'm talking about those units there. And then, just changing my screen here, we are going to look next at the powers. So we're fine with the left-hand side for now, we'll just leave it. But if I rewrite and get rid of my brackets, I've got everything that was a coefficient for viscosity, the unit for viscosity, sorry, has a power of y beside it, including the fact that we had meters to the -1, that becomes meters to the -y. We're using our power rules. Y times -1 is the new power for meters. Same idea for this velocity. We've got meters per second. We've now got meters to the power of z and seconds to the -z. So we're going to need to neaten this up even more, simplify. What that then means is we've got kilograms meters per second squared, and I'm going to multiply out all of my units on the right-hand side using power rules. So there's only one unit for kilograms, and that's going to stay with power y. I'm putting it first, just like on the left-hand side. And then with meters, I've got meters to the power of x, but I've got -y on this meters symbol and plus z on this meter symbol. So the rule for powers is that when we're timesing the term that the power is acting on, we add or subtract the powers. And that's why you can see I've got x minus y plus z. And seconds, we're using exactly that same rule. So if I look at my simplest set of units, I've got kilograms on the left-hand side. If there's no power, it must be to the power of 1. Because if it was to the power of 0, it would just be equal to the number 1. Anything to the power of 0 is 1. So that's kilograms to the power 1. That's kilograms to the power y. There's no other kilograms, so y must be equal to 1. Once we know what y is, we can think about the other terms in this equation and substitute in y equals 1. So you can see next to the seconds, instead I've got -z minus 1 instead of -y. And next to the meters, I've got x plus z minus 1 because I've substituted in y equals 1. And I think we got there pretty quick. We end up, therefore, equating the meters. We've got meters to the power 1 because, again, it's not there. And that means that 1 equals x plus z minus 1. And also, we've got seconds to the -2. That means that -2, if I'm just looking at the powers, equals -z minus 1. So, in the end, z equals 1. So that's actually the next one we'll solve for. And once you've got z, we've got the equation for the powers acting on m. And that also means that x equals 1. So a lot of you are doubting yourself. It was very interesting watching the chat. Lots of you said they couldn't believe their eyes. All of the powers were 1. If that is the answer you get and you double check it, don't doubt yourself. Okay, you've done the problem solving, you've done your method correctly, And that means that you need to commit to that answer and move on, because time will also be a challenge in the PAT, working to time. So the next question is about radioactivity. Have a little read. I'll see what's coming on the chat bar. Excellent. Lots of correct answers. Some of us are nearly there. Just make sure you start at time equals 0 with your problem solving. I wonder if that's the error. So lots of correct answers coming in, but I know I've also just put this question up. So some of you are looking at the booklet. So if you're just looking at this question, no problem, just break it down. Where are you going to start? Some people have got 2 answers and they're not sure which it is. Well done. And I'm just going to clarify for everyone, it's definitely under 15 days. So you can check quite straight away if you are within that realm. I have a few questions from earlier that I'm just checking up on. Oh, I lost where the question went. Yeah, dimensionless can mean no units, because it means it's something that we can't measure, it just has a value. A bit like, I suppose, in a different way, vectors and scalars. Vectors have size and direction. With a dimensionless constant, it's something that does not have a unit, it can't be measured, it just is. A bit like pi is just a number. Okay, so you've got lots of key information in this question, breaking it down. And you've got to start by turning those words into maths. So we've got some key statements here where fundamentally, although they give you values of half-life, the half-life of A is half, sorry, there's a lot of halves in that statement, is half the half-life of B. So yes, we've got values, but we can also see a bit of a pattern there. We've also got the initial number of atoms in the sample. The atoms, sorry, I know you said the word nucleus. But yes, we've got the original number of atoms of A. There are twice as many atoms of A as of B. So however many you've got initially, and that's what little 0 means in my subscript, we're going to have twice that number of B, and that will be equivalent to the number of A. So turning those into phrases. And also, at what time will the ratio of number of atoms of A to B be reversed? So at what point will the number of atoms of A be equal to half the number of atoms of B? So that's the reverse ratio. So turning words into maths, it is that idea from GCSE of exponential decay, and you might not have learnt that yet in your courses at the A-level standard. I don't know, for my students, we teach that after their summer exams, so it depends where you are at in your courses. But you don't need the theory of exponential decay to solve this question. I might put a slide on that up on the slide very quickly, but I'm going to just show you the problem-solving approach. So really thinking about, what do we actually know in this question? We fundamentally know that A has a half-life of 3 days. So I'm going to start by thinking in threes. I'm going to start at time 0. So anyone that got the answer at 9, you forgot to start at time 0. When we start this question, it's like the timer starts. We're starting at 0 days. And only after 3 days do we know that we have 1 half-life for the number of atoms A. So that's why you've got to start at 0 or solve this fully. Whatever you start at, you need to eventually, well, you'll see why in a second. So I'm going to work here in terms of number of atoms B, but you could take a different approach and do it the other way around. So just to clarify for everyone, the answer is not 9 days and not 6 days, but there are a lot of correct answers out there. Well done. So after 3 days, if I'm working, and what I did there was I used this rule here, where the original number of atoms A is twice the number of atoms B. So I've got number of atoms B, and originally, that's what I'm using in this blue box. I've got twice the number of atoms B. And what we then have is after one half-life, sorry, we have half the number of in this box. After another half-life, so that would be after another 6 days, I'd have half again. So I'm just working in fractions. I don't really know, unless I knew my exponential decay equation, how many of atoms B I'd have after 3 days, but I do definitely know I've got half of them because it's got a half-life of 6 days. I've got half the original number of atoms, atom B, after 6 days because it has a half-life of 6 days. So I'm going to problem solve a bit like a trial and error, I suppose, in some ways. Again, after another 3 days. Oh, and that's when I've got an equal number. So if you had a question that said, when are you going to have the same number of atoms of A as atoms of B? It would actually be after 6 days. So you'd have the same number of both of them after 6 days. But however many you started with, because everything in the question we assume to be true. So well done everyone that says 6 days, because after 9 days, we'd have a quarter of NB0 for the number of atoms A. But after 12 days, we'd have an eighth. And for NB, we'd have a quarter of what we originally started with because we've gone 2 half-lives. And so after 12 days, and I know that an eighth is a half of a quarter, I'd have, as I've said, my goal in the green, I'd have half the number of atoms of atom B. So we've got half the number of atoms B, and we've reached our goal. Just to show on the board, and well done, lots of people said 12 days quite early on. I did spot quite a few 9 days, and I think that's just forgetting to set your original rule at time 0. So especially if you haven't done this at A-level yet, and you've last done this at GCSE, it's always important to think about where you're starting and how many atoms you have at the start, where we often make an assumption that we're talking about our relative time, time 0, the start of this question. If you do know your exponential equations, you can solve it with exponentials. But if you've never seen these, don't worry yet. Or don't worry at all, sorry. Don't need to. But there are equations that you use at A-level physics involving exponentials and something called a time constant. So if you know that the half-life of A is half the half-life of B, you know that the decay constant for A will be twice the decay constant for B. And then you can do quite a lot of problem solving. I think I'll just show it really quickly, where you're equating, still using those same original rules that we worked with, but using our new exponential equations for the value of the number of atoms at any point in time. And you can even go into using logs, using your log rules and exponentials. And you can eventually prove that you get 12 days. But can you see that actually the problem solving approach, so even if you, when you have all of this A-level subject knowledge, if you haven't covered this yet, it was actually so much quicker just to work in terms of fractions and ratios, essentially, and labeling your number of atoms very, very clearly. And that was a much quicker, much easier solution than actually dealing with the more complex exponential equations that you will learn soon if you haven't already in your A-level course, and log rules. Now, you do sometimes need to use log rules in the PAT, check the specification, but that took about 4 slides of working. So sometimes it's about looking for the quicker solution. Next
Give
question.
me 1 sec and I will share the syllabus on the chat before everyone asks me for it. I'm on it.
Good point. I forgot what usually happens when I mention it.
I'm here. I'll do it. I'm just finding it.
Thanks, Kat.
Nobody panic. I'm panicking. Nobody else panic.
Next question's on the slide there. And if you are giving me a reason, if you already tried the question because you're looking in the pack, then I want a reason why as well. So if you can write it all in one go so I can read your response in the question. And just to give you a hint, if you're just starting, which is absolutely fine, because remember this question is about working at our own pace. This question is about percentage error. And I've got a hint about units.
Okay, the PAT syllabus is in the chat.
Thank you so much, Kat. This is why there's 2 of us on this session.
Yeah, I just temporarily lost it off my raft of windows that I now have open because I've been answering everyone's questions as well.
Great. Really interesting, this question, isn't it? Because it kind of boggles your brain a bit when you think about it. Because it's kind of unbelievable when you get the answer. But you've got to work with the information you have in the question and the details you have in the question and the assumptions that you can make. So I'll show you my next step and hint. You're given information. You can only use the information in the question here. I mean, sometimes you need to use things like acceleration due to gravity, but not in this question. You're given the diameter of the snooker ball that we know well, and the Earth with Mount Everest's height, the radius of the Earth. So you are given diameter of the snooker ball and the radius of the Earth. But I want you to think about, as a fraction of the Earth's radius, we're given Mount Everest's height. So we are given Mount Everest's height, h. And that means we can consider that as a percentage uncertainty, so like the biggest sort of percentage deviation on the Earth's surface, because nothing's taller than Mount Everest. So we're going to take that as the least smooth part of the Earth's surface. Okay, so well done. I think lots of people are working in decimals as well, and lots of people have gone back to check their answer. I say majority are getting the correct answer. Why don't you have a go and double check the snooker ball's uncertainty in the same way? So we're given the diameter of the snooker ball in centimeters, check your units, and the uncertainty on that diameter. So the uncertainty on that diameter. And make sure you can prove it with data. Well done. And don't worry about one of them being diameter and one of them being radius. I'll address that in a minute. But we've got the radius of the Earth, so the distance from the center of the Earth to the Earth's surface. And then imagine Mount Everest is right next to that. That's the really not smooth part. So that's the uncertainty on that radius that you're given, which is why we get that percentage. So for the snooker balls, so we've just worked with that percentage for the uncertainty where Mount Everest is. It causes an uncertainty or a lack of smoothness of 0.1389%. The snooker ball is 0.245%, the uncertainty on the diameter, the manufacturer's value of uncertainty on the diameter of the snooker ball. So be really careful with your units there, because yeah, the Earth is smoother in this question. And that's the one that always surprises people. But if we think about the scale of a snooker ball compared to the scale of the Earth, and you've proven it through the percentages that you have there, Mount Everest actually causes much less deviation in the Earth's surface compared to the uncertainty or the lack of smoothness of a snooker ball. But we can picture a snooker ball because we can hold it in our hand. Can't quite do that with the Earth. So it doesn't matter. And remember to put questions in the Q&A, but I knew that the question was coming. That we've got radius for one and diameter on the other, because Mount Everest adds to the radius of the Earth. We're given the radius, and we know Mount Everest is a big deviation from that radius. If the question gave us different information, we might work in a different way. But even if we had double the diameter, we've got to think about how much would that actually impact this answer. In terms of the snooker ball, you are given the uncertainty on that diameter, so I can only compare that percentage for the given values, and that's what will indicate the smoothness of the snooker ball. You're given the uncertainty on that whole diameter.
You've got a few questions in the Q&A as well, Rachel,
Great,
just to alert you to open a different window, because I know you're very focused on the chat at the moment.
Okay, brilliant. So some good questions. Why don't you have a go while I read some of these questions at calculating the highest mountain if a snooker ball was enlarged to the size of the Earth? So that's the next step on that question.
Excellent. Rachel, would you like me to talk for a minute while you type some answers? Would that be useful?
Very much. Perfect.
Amazing. Once again, our dream team comes into play. So I'm going to answer a few questions that have come up again. We find that throughout these webinars. Before I do, I just want to make really clear today as well, we have another 8 webinars with you, as well as you can always email us. So if something doesn't get answered today, don't worry, we'll get to it in the end. But a few things that are consistently coming up are about the fact that it's multiple choice. And again, I just want to reassure you that behind the scenes, we've done a lot of work selecting answers and we get a lot of information from you. But a few things, we do not give negative marks, so we will not remove marks for incorrect answers. Secondly, it's important what you select. It's not that one answer is correct and all the others are wrong. All the others give us some indication of how you tackled that problem. So we get a lot of information from you. Other things that have come up, people asking about the syllabus and about things that they haven't covered. The PAT syllabus is online. I shared it a little bit earlier, but I'll share it again repeatedly over the course of the Preparing for the PAT course. Everyone will have some degree of independent learning to do, whether that is simply because you do a different exam board and so you've covered some different things, whether you're from a different country. The variations in what people know at the start of year 13 are almost infinite. So take a look at our syllabus, and if there's something you haven't covered, get started, get stuck in. There are loads of great resources to help you find, which leads me nicely on to another question coming up, how to prepare for the PAT. Firstly, we're here. This is a great way to help you prepare for the PAT, along with all of our questions. All of our past papers are online, so you can find our past papers. And then one thing I like to recommend to people is almost go small. A great way to prepare for the PAT, which we think of as familiar physics and maths but in unfamiliar context, is to do something like grab a different exam board's textbook. Try some questions at the same sort of level as you, but from a different country. That's a great way to get practice at solving questions at the appropriate level in a whole different context. So that's a great way to do it, and I'll share some of those tips in our emails as well. I try not to make the first email 4,000 lines long. We build up as we go through the course. Then there are some other questions, and I think so far I've only answered 9 people asking me, but really, what is the PAT score to get an interview? So you're doing well. Sometimes I get up to 100 of those in an evening. And I've typed exactly the same answer to everyone, which is there is no fixed score which will guarantee you an offer of a place in Oxford. We look at every single application as a whole and as an individual. So yes, we want a good PAT score, but we also want to know about you, and we look at every single piece of information. So you will see over the years that there are people with very low PAT scores who end up getting a place. There are people with very high PAT scores who don't get offered a place after interview. So there is no specific PAT score. I have also clearly switched into more of an accent than I usually do because Zoom has just asked me to confirm my speaking language and let me know that I might have switched to a different language. As far as I know, I'm definitely still speaking English, but occasionally my Scottish accent does come into play. Don't worry, although Zoom isn't fond of my accent, we accept all Scottish qualifications at Oxford as well. I've also been asked quite a few times about calculators. I've shared the link a few times, but again, I will share, you can just give the calculator a go. So I think I've covered a few things. There's a few people asking, are you going to get a formula booklet, things like that. Simple answer is no. It's a basic scientific calculator and there's no formula booklet. It very much mirrors the actual Oxford exams. So keep an eye on that. It's a good idea to have a rough idea of constants as well. And again, even as I am speaking, people are asking again, but really, is an interview guaranteed with a high PAT score? Not necessarily. There is not a fixed score. There is a formula that we use which gives us a rough idea of how we can combine factors. So, for example, all the information on your UCAS form, including GCSE scores, but that formula just gives us a starting point. Once we have that starting point, we then go back and we bring a lot of people back into that interview pool. So there's a lot more to it than just good PAT score. As a result, I am now going to dismiss all questions that in different words ask me, but really, what is the right PAT score? Because there is not a fixed answer. Rachel, how are you getting on? Would you like me to stop rambling?
Oops, sorry, never rambling.
How are you doing? Good.
I answered a few. I can come back in a few minutes, but I think we can move on with the question.
Okay, great. I'll go back and answer some more.
Yeah, maybe 5 or 10 minutes. And it was helpful seeing a few. Yeah, definitely. I think a common theme is people noticing the plus and minus uncertainty, but that's saying that this question is just saying that the absolute maximum certainty on the snooker ball could either be plus 0.127 millimeters or minus, and you then don't have to overthink that a maximum could be right next to a minimum. It's like the manufacturer is just giving that uncertainty. And there are some questions in A-level physics, for example, if that's what you're sitting next year, or doing, mock exams this summer, that just give you the uncertainty from the manufacturer. So also some people are reading into the final decimal place and things like that. And I know that's how you read uncertainty from a table. And you can make an assumption that the precision of the equipment you're using is shown by how the data is presented in a table. But also things like if you're measuring length with a ruler, we use that rule in A-level, where yes, a measurement at the beginning and the end, the uncertainty is plus or minus half a millimeter, but the measurement on the whole length of something, because you're making two judgments, the uncertainty on a ruler is 1 millimeter, for example. So I think lots of people are kind of muddling their rules there, whereas in this question, you just need to use the uncertainty that you are told and treat that as a percentage of your total diameter or radius. Because you can kind of assume that you can trust that information in the question. Although I do like your problem-solving brains. Definitely everyone was thinking quite hard about that question. And if you haven't looked much at uncertainty, I'd probably there's a lot of resources out there for A-level physics on uncertainty, but this is just basic uncertainty in this question. This is just, if you think about it, it's like a percentage error. Like, what is the biggest percentage error that the snooker ball or the Earth could have? And well done, loads of people sent this result in, that on the Earth, we'd have a kind of 15-kilometer mountain if it was as rough as that snooker ball in the question, which is quite unbelievable, nearly twice the height of Mount Everest. So it's all sort of a sense of perspective. Oh, Kat, I actually forgot that this is my final question. So we could answer any more questions if we need to. I will reiterate my hints for a moment. So really make sure you're decoding the questions. Don't rush into it. If you need to write a list of sort of what each part of the question means and turning the questions into words on your sort of whiteboard or your piece of paper when you're practicing, then you've got to do that so you can accurately problem solve. Don't rush and make sure you're laying out any formula that you're using, turning words into symbols, making sure you're decoding phrases like if x is twice y, we can decode that to x equals 2y. I think you were excellent at that today. So next week you will have a workshop, and I will look at the questions in the Q&A as well and see if there's any more to answer. But Kat, anything else to add this evening?
I have a very important thing to add, which I would like to say because I realise I've forgotten to add it. The PAT is completely free to register for and to sit. So anyone who's asking about costs, it is completely free to register and to sit. So there's nothing like you're going to have to pay twice. I've had a few people asking about that.
Some good reactions there.
Yes, everyone seems very happy about this. Whew. Okay, flicking through the questions to see which one of us has got more. You have right at the top, Rachel. You've got a couple of questions. One going back to our lovely caterpillars, so someone who got a little bit lost.
Yes, I saw that. I might go back to that one.
That would be great. We can kind of take this in
Fantastic.
stages.
So the question was, where do I go from solving the 3 simultaneous equations? I subtracted 2 equations and I have the length. So just getting back there now. Sorry, I'm sure there is a quick way. Oh, I can't remember how to get there right now. Here we go. So we're back to the caterpillars, our favorite question. Back to the point where we've got the 3 simultaneous equations. And there's like more than one route, I'd say, at this point. And this is the point where you can choose your next step and where you want to go. But remember, I said that I was prioritizing. I knew that I need the length of the violet caterpillar eventually, so I don't want to cancel that through my solving simultaneously. And if I'm looking at my equations, the length of the violet caterpillar is in equation 1, and that's a lovely simple equation where there's only 2 terms. So I probably don't want to cancel in my substitution length of the mauve caterpillar. So what I said I did was times through by equation 13 times through by 5 over 3. And the reason I chose 5 over 3 was because I wanted to get the same term as equation 14, 5L out. I want to cancel by solving simultaneously. And so I'm going to then subtract my new version of equation 13, which is in the light blue box, from equation 14. And I think this is where the question said they had got to. So we subtracted one from the other, and we end up with the length of a mauve caterpillar, but still with some fractions, and in terms of length of the violet caterpillar. So we then have to look back at our original length equations, and we have to remember where we're heading, that the velocity of a mauve caterpillar, eventually I'll need the length of the violet caterpillar. And I've got the length of the mauve caterpillar here in terms of length of the violet caterpillar. So I scan through my equations. I've just done a bit of work to cancel length of the violet caterpillar. So I'm not interested in 2 and 3. I'm only interested in equation 1 to help me solve this. I'm going to substitute in the length of the mauve caterpillar into equation 1, making sure I use my brackets and work systematically. And when I do that, we go through these stages here. So we're using equation 1. We're substituting in the length of the mauve caterpillar, 3 over 10. You can see we're working through our fractions. So 5 times 3 over 10, you get 3 over 2. We'll end up cancelling the 5s, and that's why 5 was a good number to work with. So I could also see a 5 in this equation. And you might have multiplied through by something else at some point, but eventually you would end up with this simplification as long as you've worked accurately with your working. So we end up eventually with 3 over 2 equals 30 times the length of the violet caterpillar. And that's the key to this question, calculating the length of the violet caterpillar. And then once we've got the length of the violet caterpillar, we can substitute that in, get the speed of the mauve caterpillar, a lot of caterpillars here. And then we can find a value for that speed. And once I've got speed, the goal of the question is how long it would take it to crawl around the equator. So I've got time, I've got speed, I've got radius, but the equator is modelled as a circle. So that's where we work with 2 pi r, the time for the mauve caterpillar to go around the equator of 2 pi r, divided by the speed that we've just worked out. And that's how we get that final step. Okay. So I'll see if there's any more questions or things.
Yeah, I think you've got a couple about the uncertainties in the snooker ball. So that might be a good one to do. I've got a few. So questions about the ESAT versus the PAT while Rachel scrolls through those. As far as I know, the ESAT is not free, but because it's not an admissions test we use, I am not an expert on that, but you'd be able to look it up and find out. We do not look at your ESAT score at all. So if you happen to need it for another university and you end up sitting both, we don't look at your ESAT in any way. So good luck to you, but you don't need to worry about that. I've had a few other questions about number of A-levels. For Oxford in particular, we have no preference as to whether you're doing 3 or 4. So our offers will only ever be made on 3 A-levels. I know that when you go on to places like UniFrog and UniStats, it might tell you that many of our students who were successful did have a 4th A-level, but we don't consider it in our application. So you're not at an advantage if you take 4, you're not at a disadvantage if you take 4. It's just not a consideration to us at all. It is your own personal learning journey. Our offer will be based on 3 or equivalent. Please, whenever I'm saying A-level, take it as read that this is for all equivalent qualifications. You can find exactly what we take. For anyone who is happy with the problem solving we have done today and has no further questions about the PAT, we are simply going to be answering questions based on tonight's problem solving and on anything else that comes through for the last kind of 5 minutes or so. And I'm certainly not going to be offended if you want to steal back 5 minutes and go and get yourself an early cup of tea. So go for it. If you've still got questions though, by all means, hang out. We will be here until 8 o'clock answering your final questions. Some people have asked about whether or not you can take the PAT when you're not applying to Oxford and then tell other universities how you got on. Simple answer is no. So you can only take the PAT if we are able to match your PAT registration to a valid UCAS application. So come the 15th of October, once your UCAS form is in, and that we will cross-reference PAT with UCAS. And both of those things need to be in for us to allow you to sit the PAT. The simple reason for that is simply to prevent fraud. So it means that we have no one going into the PAT just to memorize questions, for example. So everyone who is sitting the PAT has to also be applying to Oxford. So you wouldn't be able to sit it without applying to us. We've had a few questions about the kind of difficulty themselves. The questions we have chosen today are from PAT past papers. However, we've not chosen them to be representative of the entire range of difficulty or question type on the PAT. We have chosen them because they reflect a particular set of problem-solving skills that we wanted to discuss with you today. For example, the simultaneous equations, the uncertainties, the making assumptions in the projectiles question. So we've chosen these questions with that in mind. So if you're curious, yes, these are PAT past paper questions, but they're not going to be reflective of the test as a whole because you can get so many more questions in the test. I've had a few people asking really specifically about minute to mark ratio, and honestly, off the top of my head, I just can't quite remember. So we can look up number of questions, we can come back to that. We've got until October to get you there, so we can get you to that point. What else have I got? I'm going to scroll up now. I've got a few questions about interview. Lots of questions about personal statements. We consider every single application that we receive in its entirety. So it will be read, we will give it some thought, but it doesn't form a huge part of our consideration. So in terms of how we're weighting them, the test and your exam scores are far more important to us. So personal statement is very much, we do read it, we love to hear about them, but it doesn't have a major impact for us, simply because we get so much more information from you. because we get this idea not just about your problem solving skills, but about where they lie in terms of maths and in terms of your physics and in how you have done on that. I can see that I've got quite a long question about interviews. If you are invited to interview, you will have at least 2, usually 3 interviews covering maths and physics between 2 different colleges. There are additional philosophy exams for anyone who is applying for physics and philosophy, which is one of our courses which is available to you. But there is no disadvantage to students who have not sat a philosophy admissions test for that. We know that you're applying via the PAT route, so you don't need to worry about that one. Hopefully I got that. I've answered personal statements. I've answered how long the class is. I've admitted that I can't answer minute to mark ratio. Oh, I've had a few questions about quotas and that do we have a specific priority for home or international students? Honestly, no, we don't have a fixed quota or a fixed number for any group of students. We just look at every application as and when we get it. So we typically end up with about 70% of UK students, but we're not bound to that, and that figure will go up and down each year depending on the individual applicants. And hopefully that will make you feel a bit better as well, which is that we do have this variation year in, year out, because we want it to be fair. And actually, while I remember that, a few people have asked about specific college choices. We have only a few principles in our physics admissions policy, and what we absolutely enshrine is that every applicant should have the same chance of getting in regardless of what school they went to, and every applicant should have the same chance of getting in regardless of what college they list as a preference. So you'll notice I'm being quite careful in my language and I'm saying your college preference, not your college choice. We will make sure that every college interviews roughly the same number of applicants per place, and we will make sure that everyone who is deemed worthy of a place gets a place somewhere. That means it may not be at your first preference college, but it helps us ensure that we have that fairness. You don't receive your scores immediately after the PAT. If you are unsuccessful, we release the scores in January. If you're successful, you have to ask us specifically. And the other thing I think that most people have asked, as in the most number of people have asked, is about GCSE scores. We do look at it, it forms part of our application, but do not be put off applying if you don't think you've got the GCSE scores for it. Give it a go. A really good PAT score, a great interview, a good application, good predicted grades, all of those things are far more important than your GCSEs. We all grow as people, we grow professionally and academically so much throughout our careers that we hope we value that in you as well. That does bring us to the end of our very first Preparing for the PAT webinar 2025. I am very aware that we still have some questions answered, but to give you some context, I have personally answered 121 questions already this evening. Rachel has also taken a share of those, so I shouldn't take full credit for it. If there is anything that we haven't got to, please be reassured we have another 7 webinars, but also feel free to drop me an email. I'm happy to help. We're here to support you for your entire journey towards sitting the PAT in October. So if anything's worrying you, get in touch, but we've got 7 webinars. We'll probably get to you in the end. Rachel, thank you so much for joining us this evening. I believe we'll see you again in 2 weeks' time. Is that correct?
Absolutely. Sorry, I lost my audio button just then.
No,
well done, everyone.
good.
Thank you so much for your participation. You've been a fantastic group. It's really important to keep up with your practice from here, whether that's through the things that we're sending you or independently. You can do both. Okay, so problem solving is all about practice.
Lovely. With that in mind, I am going to set you some problems tomorrow. And next week, our webinar will be led by some of our undergraduate students who will take you through their own problem-solving approaches. The following week, webinar 3, Rachel will be back talking about a specific topic, optics, one of both of our favourites. But for now, it is goodbye from us. We will see you next week, and I will email everyone tomorrow. Goodbye, everyone.